Welcome! You found the video, so you've really completed the most important part of this assignment is just to find this video and be able to play it and listen to it. But what I'm going to do for the rest of my time as your homework is to kind of recap some of that summer homework that you had, that prerequisite chapter 0. And I didn't assign all the sections in it, just some of the ones that I think will be more important to us in this first semester. So normally you're going to be introduced to a topic in the video, and then we'll recap it or just summarize it and highlight it together in class. But I'm going to go ahead, since you've already been doing this all summer long, you should have found these sections fairly straightforward as reminders, some practice, and I'm going to hit you some highlights and emphasis that I like to put on things. So let me do that now for you. 0.1 was all about domains and ranges. And we talk about domains normally as your x values, ranges normally as your y values when we're doing functions that are, y is equal to some function of x. But these domains and ranges can be for any kind of relation, where you start with an x value as your input, or any value as your input, and you have some other value as your output. Okay? And they have lots of multiple representations. You should be familiar with ordered pairs, mapping diagrams, table of values, anything like that. Graphs, obviously, that are a multiple representation of how x and y relate to one another. So that's the language we'll use. The difference between a relation and a function is simply a function. There's only one y for every given x. So a function, of course, if you know x is 2, then y is 3, and every time x is 2, y will always be 3. So you kind of know what you're getting. It's a very orderly type of thing. You put in a 2 in this black box of a function, and out pops the 3 for your output value, which we normally call y. So, okay, that was 0.1. You should be familiar with domain and range. Okay, next section. 0.2 was all about what many of us call FOIL. This is a word that I certainly did not learn when I was your age. We called it repeated distribution, and the nice thing about that versus using FOIL is that repeated distribution can be expanded. FOIL, this first, outer, inner, last, only works if it's a binomial times a binomial, which is what this section was all about, so it works every time. But you won't always have this special case, okay? So I really would like you to think about this as repeated distribution for when we do more than just a binomial times a binomial. So obviously, you're familiar with FOIL. You should be able to take A plus B and multiply C plus D, okay? Those are two binomials. So that should be fairly straightforward. I don't want to see arrows. I don't want to see happy faces. I don't want to see this, okay? Yes, that's exactly what our thought process is. The A is distributed to the C and D, plus the B is distributed to the C and D. But here we are in the honors math class. We want to be a sophisticated math student. You can certainly do that process in your head and write down the answer, okay, without the arrows. So no arrows, please. There's going to come a time when there's so many other things going on. We want to get really good at these simple things. The other thing is when we're working with the most common type of foiling, and this is certainly what you're familiar with, I don't need you to write out the first, the outer, the inner, and the last terms, and then you simplify them, because remember that outer and the inner in this case will be like terms that you can combine, the 3x plus the 7x, right? So what I want you to be able to do is write this down without that intermediate step. So x squared plus 3x and 7x is 10x plus 21. No need to write the middle. You'll save yourself a lot of time, and let's just keep moving on in these problems. Notice there's a 1 in the coefficient of both x's here in the original, and the coefficient of 1 in front of x squared here. And I want you to notice that this is going to be very similar to 3x plus 1 and 7x plus 1. And what's the same about these, let me write it down real quick, is the middle term. Okay, so that middle term didn't really matter if the 1 was a coefficient here or if it was the constant term there. So this middle term that you get by adding the two like terms from the outer and the inner is going to be very important to us, especially in the next section when we start factoring. So I want you to take a lot of time practicing looking at these problems and just quickly getting that middle term very quickly, you know, not necessarily looking at the first and last, but getting the middle term quickly. All right, moving quickly through 0.3, which is all about factoring, and we're going to be doing a lot of this all year long, all your career in mathematics, and you're going to hear me say these sorts of things over and over and over again. When you see something and you want factors rather than terms, and there's lots of reasons why you would want to factor something, so that you end up with factors that are multiplied together instead of having terms that are added together, okay? Multiplication is a much simpler operation to deal with. So that's one reason. But okay, so what do you do when you decide that you need to be factoring? So the first thing, of course, is always that GCF. You can't really begin until you've taken greatest common factors out first. And this is oftentimes somebody's having trouble factoring something that can't, you know, figure out what factors there are, and it's because they've forgotten to do the greatest common factor first. Okay, and then after that things will get a lot simpler. So, and there can be any number of terms for finding GCF. So we have that strategy. Your second strategy is to look, of course, for specials. So we have some special types of factoring that jump out at you, like the difference of squares, a squared minus b squared. Okay, it would be a difference of squares, that's one of our specials. Notice there's only two terms for this particular special, and there's also factoring when you have, I missed the plus sign there, when you have a trinomial, these three terms, and I hope you recognize this one as your perfect square trinomial. All right. But what we'll spend the most time on is trinomials that are not special, and so we'll be needing to unfoil those. Okay, so we're going to unfoil trinomials, which is a way of saying factor them, and it's kind of the method you use. And I'm just going to reiterate this over and over again. Start with the multiplication, okay? You'll hear me say that, and let me explain what I mean. But first I want to give you an example and point out what I don't want you to do in our honors class is to say, okay, I want to write down all the factors of x squared, well obviously x and x, and I want to write out all the factors of 20, 1 and 20, 2 and 10, 4 and 5. Please, please break yourself of this habit. We don't need all that, because you can do it much simpler and quicker and become much more fluent without that. It is, of course, what you're thinking. You start with multiplication, so what are the factors of 20? You just went through them in your mind. Which one of those give you the correct middle term? And of course, the middle term is what we worked on last section by adding those two together. So obviously 4 and 5 make 20 with multiplication, and then they add to 9. So I do get my middle term, but I start with the multiplication and then check the middle. Notice this is fairly easy. There's no reason you can't just write down the answer when there's a coefficient of 1 in front of x squared. Super simple. Okay, but I also want to point out to you this same process works when the 1 is not in the beginning, but rather it's at the end. It's exactly the same kind of problem. So obviously the only way, working on the ends first with multiplication, the only way to make the 1 is 1 and 1. Okay, so obviously 1 and 1. The only way to make 15x squared, well actually there's two ways, right? But which one of those will give you the correct middle term? And the answer is obviously 5x and 3x. And I'm using all pluses in my examples for simplicity. Obviously we'll work on the pluses and minuses just as a practice in class. Okay, but obviously you don't always have the 1 on either end, and then this is when things start to get a little more interesting. You have to be a little more creative. So I break these down in choices or no choices. So let's take an example when we don't have the 1s on either end and we want to factor this trinomial, because right now I have terms and I would prefer to have factors. So if you look at this, and remember we start at the ends, the 2x squared and the 3 are on the end, and we work with multiplication first. There's only one way to make 2x squared, there's only one way to make a 3. Well, I'm going to go ahead and write them down because those are my only choices. Okay? But here's where I know it's a 3 to 1, but there is one choice to be made, and that's a question of order. Do I do 1 and 3 or 3 and 1? And that makes a big difference. You know, write it out, try it if you have to. But I recognize that I need 6 and 1 to make the 7, so I want this to make the 6 and the 1. So the 2 and the 3 multiply together, right? It's how quickly can you get that middle term. And obviously when I put it this way, I get the 7x as a middle term. So no choices as far as the numbers go, but just a question, the only choice is where to put them. Okay? So that's one type of problem when there are no 1s that make things easy. Here's another one. And here I'm going to have lots of choices. So, you know, I've always said I don't want to see you writing a lot of things down. Well, here you might have to write some things down. I call it guess and test, okay? Try different choices. If it doesn't work, try something else. And don't forget to try changing the order as well as changing the numbers. So I'll go ahead and get started. I know I've got 2 parentheses. I have fewer choices for how to make the 6. So let me start with my favorite way to make a 6, just to pick one, either one. 3 and 2. But now I know I have to make the 12 as part of x squared, so I got to think about that. I really don't know. My favorite way is 4 and 3. Now if I go with 4 and 3, remember, this has no GCF in it, right? So that means none of these should have a GCF, okay? So if I want my 12 to be made with 4 and 3, I can't put the 3 here, okay, and the 4 here, because then each of those actually would have GCFs in them. So don't put numbers where they would be GCFs if there wasn't GCF in the beginning. And remember, there won't be a GCF in the beginning because you would have taken it out before you even started this process. So I know I want to make the 12 with a 3 and 4, but I know it's not first the 3 and then the 4 the way I've set it up. So it could be a 4x and a 3x this way. Okay, excuse me. So that's a better way, to go and try this. I have no idea if my middle term's going to work out yet. Okay, I've just picked some numbers and I've put them in order so I don't have GCFs. Now let me try the middle term. Here I have the outer terms make 8, and the middle inner terms make 9. 8 and 9 make 17. I happen to come across it pretty quickly. It won't always be so quickly, so you may end up having to cross them out, erase them, and try again if it didn't work. Okay? But I wanted to show you this no GCF trick. Finally, I had to do some work with the Pythagorean theorem because it is so important. Okay? It's fresh in your mind, hopefully from geometry. And I promise you, you will see it on the PSAT coming up in a month or so. Generally, if you're stuck on a geometry problem in SAT, it's probably Pythag. Okay, so it's important, and we want to make sure you just stay familiar with it, keep it fresh in your mind. And I don't have much to say about it. I will say the one thing you have to remember is always the guy by himself, which I've labeled c squared, is the hypotenuse, okay? Don't, you want to make sure you have these all in the same, in the right order, and the hypotenuse, and it doesn't matter which one of the legs is A and which one is B. Okay, so you want to make sure that the side C is opposite the right angle. That's what makes it the hypotenuse. And you should also notice that, excuse me again, that C, the hypotenuse, is always the longest side. So notice that, if sides are 3 and 4, the hypotenuse is longer 5, okay? Classic 3, 4, 5 triangle, and that's another good thing to take with you to the SATs.